factoring, and we should be able to do it in one video. So we keep our fingers crossed. So in the last video, we talked about the greatest common factor. So we have now 3 types of factoring we're going to talk about in this video. All right. So at the top of your page, it says always check for A. And we're going to say in this box, I want you to write the word GCF or greatest common factor. You always want to check for that. For our purposes, most of the problems won't have greatest common factor, but there are some times if you're taking the SAT or ACT or the ASVAB, then there may be a greatest common factor first, and then you have to factor using one of these methods, using this method. So the first type of factor we're going to talk about is factoring trinomials where our A or our leading coefficient is positive 1. All right, so again, we're going to do a couple of examples and just follow along with me on this. All right, so let's start with the number 1. All right, so we have x squared plus 9x plus 14. All right, so before you get started, I had you copy down a list of rules. Now, those rules you'll be using not only for the rest of this unit, but also, like I said, we may use it on future problems as well. So you'll need to apply these rules. Now, I'm not going to show you the rules just because for the sake of time, but I will reference them. All right. So if you look at the problem number 1, we have x squared plus 9x plus 14. So in order to solve this one, what we have to do is, and again, follow along with me, you're going to do an x. All right. So the purpose of the x is we need to find in the top of the x, we're going to put 14. In the bottom of the x, we're going to put 9. Okay? So the way I'm showing you, when I was your age, one of the things I had to do this in my head, but as mathematics has evolved in the many years since I've been in school as a high schooler, they've changed kind of how this works out. But it's still the same idea. It's just more visual. And so students tend to do well with understanding it that way. All right, so what we're looking for in the sides of the x are 2 numbers that when I multiply them, they give us the top number, 14. And when I'm adding them together, I get the bottom number, 9. All right, so here, we want to come over here to the side, and we want to list our factors of 14. So factors are 2 numbers when you multiply them together to give you 14. So I have 1 and 14. So that's my first set of factors. Then I have 2 and 7. Well, I can go down the list of other numbers to see if they're factors, and that's usually what I recommend. So if we do 14 divided by 3, we know it's going to be a decimal or whole number. If you doubt me, you can always check with your calculator or decimals. But I'll go and tell you that 14 divided by 3 is a decimal or whole or fraction. You don't want that. Then we do 14 divided by 4. That's also a decimal or fraction. 14 divided by 5, decimal, fraction or slash fraction. 14 divided by 6 is also a decimal or fraction. When we get to 14 divided by 7, we wind up with 2. But see, the thing about it is we've already used 2 and 7. So we don't need to use them again, even if they're in a different order. They're the same 2 factors. So now we've identified all of our factors. And so what I recommend, guys, is always start from the bottom and then move to the top. Sometimes you may know all the factors. Other times you may have really big numbers, and which we don't really do really big numbers in this course, but it is possible. All right, so now we've listed both of our factors. So now we need to see which of these, if we add them together, then we will get 9. Now, I'm going to reference the rules I gave you. Now, if you look at the first sign, this is where I said first sign. That's positive, so I'm going to write first above that. And the second sign, which is right here, is going to be positive. So if you look at your rules where it says the first sign is positive and the second sign is positive, then the rule states that both of my numbers are going to be positive. So I'm going to put a plus sign by both of my factors. All right. So 1 plus 14, that gives me 15. And then 2 plus 7 gives me 9. So we can stop there, 1, because we are at the end of the factors. But if you happen to have put 2 times 7 first, you could have stopped there, because if you notice, you had two sets of numbers. When you multiply them together, give you 14. But when you add them together, you're only going to find one set of numbers that gives you the bottom number. So we're going to put a 2 here and a 7 here. Now, the order of this doesn't matter. If someone says 7 times 2 first, as opposed to 2 times 7, then it still comes out the same way. So now you're going to come over here, and you're going to put x plus 2, parentheses, x plus 7. All right? And so now we have completely factored it, and for our purposes, we're going to stop here. We're going to stop at that point. We don't have to go any further. So we have now taken x squared plus 9x plus 14 and turned it into x plus 2 in parentheses times x plus 7 in parentheses. All right, so let's move on to example number 3. All right, so next thing we want to do here, again, we want to draw our x, and we're going to put in this time negative 14 at the top and positive 5 at the bottom. All right, so we come over here, we list our factors of 14 again, and we got 1 and 14 and 2 and 7 again. All right, so next thing you want to do is look at your signs. So your first sign is positive, and your second sign is negative. So looking at our rules, when the first sign is positive and the second sign is negative, that means that the bigger number gets the plus sign. The larger number gets the plus sign. So we're going to put a plus by 14 and a plus by 7. So that means the smaller number, which in the first set of factors is 1, gets the minus sign, and with 2 and 7 is going to be 2. So now negative 1 plus 14 is 13, and negative 2 plus 7, that's 5. So that means my factors are negative 2 and positive 7. So I'm going to come over here and rewrite it as x minus 2, parentheses, x plus 7. So again, the order doesn't matter. If you want to say x plus 7 first and then x minus 2 second, that's fine. You will get the same answer. All right? So that is simply factoring whenever our leading coefficient is 1. If you notice that there was a 1 here on number 1, and there was a 1 here on number 3. So this method works only if we, first of all, have 3 terms, and the first number of the first term is a positive 1. What happens when it's not positive 1? So that's going to be our second type of factoring. All right? So here, we're going to do a technique called slide and divide. Now, I apologize, it's a little long, but again, just follow along, write the notes, and then when I'm back in person with you, we'll kind of do a couple more examples like this and hopefully submit this. All right? So next you want to say, with slide and divide, the first thing you want to do is you want to slide the number to the back. And when you slide it, you're actually multiplying it. All right? So 2 times 9 becomes 18. So the 2, once you slide to the back, it disappears from the front, and you're left with 18 in the back. So now it looks like example 1 and 3. So we're going to come over here, do our x again, and then we're going to list our factors. We're going to put 18 on the top, 11 on the bottom. Since I'm running out of room on that side, I'm going to write 18 over here. And I'm going to say 1 and 18, 2 and 9, 3 and 6. Okay, those are the only 3 factors. So now we're going to follow our rules. The first sign is positive. The second sign is positive. So according to our rules, if the first sign is positive and the second sign is positive, all the numbers are positive, meaning both of our factors are positive. So I'm going to put a plus sign by all my numbers. So please do that as well. All right. 1 plus 18 gives me 19. 2 plus 9 gives me 11. So I can stop here because remember I told you, if you get your factors to give you the bottom number, you don't have to keep doing all the factors. And when you get really a long list of factors, it will save you some time. So we're going to say 2 and 9. So we come over here and we write it as x plus 2, parentheses, x minus 9. All right. So the next thing you want to do is, remember I told you this was called slide and divide. So here, I'm just going to actually write it up here. So slide and divide. So again, if you want to write that too. All right. And that's again when a is not equal to positive 1. So the dividing part is we take the number we originally started with, which was 2, and put it under both of our numbers. So now what we want to do is we want to do one of 2 things. We either want to simplify it to a whole number, or if possible, or put the fraction in lowest terms. All right. So 2 divided by 2, that's positive 1, right? So we can simplify that to a whole number. So we're done with that one. Well, 9 over 2, negative 9 over 2 does not become a whole number because negative 9 over 2 becomes a decimal, and we don't want that. Whenever it becomes a decimal, we want to make sure it's the lowest term. So 9 over 2 is the lowest term. There's no greatest common factor. We can divide by and make them smaller. You're going to take that bottom number and you're going to slide it in front of the x inside that parentheses, okay, in that same parentheses. So then it now becomes 2x minus 9. And now we've successfully factored whenever we have a trinomial and the first term has a leading coefficient of something other than positive 1. All right. Let's move on to example 6. All right. So we're going to do the same thing. 3 is our greatest common factor. 3 is our leading coefficient. So we're going to multiply. We're going to slide to the back again, multiply. All right. And that now becomes x squared plus x minus 6. All right, come over and do our x again. We're going to put negative 6 here and positive 1 because there's not a number in front of the x term except for positive 1. So that's why we have to put a positive 1 there. So again, I'm going to come over here and there's my factors of 6, which are 1 and 6 and 2 and 3. Okay, the first sign is positive, the second sign is negative. So going back to our rules, where the first sign is positive and the second sign is negative, that means that the bigger number gets the plus sign and the smaller number gets the minus sign. So negative 1 plus 6 is 5, and negative 2 plus 3 is 1. Okay, so our factors are negative 2 and positive 3. All right, come over here and rewrite it as x minus 2, parentheses, x plus 3. All right, so remember what I said, we're going to go back to the number we started with, which in this case was 3, and divide both of our numbers by 3. Well, 2 divided by 3, that doesn't come out to be a whole number, and it is in lowest terms because there's no greatest common factor between 2 and 3. So that means we're going to slide the 3 to the x inside the parentheses. So we got 3x minus 2. And over here, 3 divided by 3, that gives us 1, right? So then that becomes x plus 1. And now we have successfully factored 3x squared plus x minus 2. All right? So one thing I did not mention earlier, one thing I like about factoring is there's a built-in check system. What you can do is take these two binomials here, and if you do FOIL or the box method, you should wind up with what you started with over here. Okay? So if you doubt your answer, I would just do FOIL or double distribute or the box method, and you should wind up with what you started with. If you didn't, then that means you need to come back and check something, okay? So I'm going to erase this part here. All right. So now let's finish up the last bit of factoring. So the difference of squares, I'm going to give you a general formula for this one because the other ones didn't have a general formula. The general formula is a squared minus b squared. So a squared is a perfect square because 2 is an even number, and b squared is also a perfect square because 2 is an even number. All right? This works when we call it the difference because difference means subtraction. So this right here, this minus sign. So if you have a perfect square minus another perfect square, the way you write this formula is you're going to find the square root of each number, which a squared becomes a, and you're going to do 2 sets of parentheses. And you can find the square root of b squared, which is b. And then you're going to put a plus sign and a minus sign. So to me, this is one of the easiest factoring to do. And that's why I said it shouldn't take that long to go through it. All right, so let's do example. We're going to do examples 7 and 8 this time. All right. All right. So first thing we want to do is look at x squared. Okay, that's a perfect square. 4 is also a perfect square because I have a perfect square list on the board in the room. All right, so now we're just going to rewrite it as x and 2. And again, the order doesn't matter. So in this case, let's say we put a plus sign here and a minus sign here. X squared, square root of x squared is x, and the square root of 4 is 2. So we just separate out, and we've done that problem. All right. Next we're going to work on is problem number 8. All right, 9 is a perfect square as well as 64. There's a minus sign in between them, and x squared is a perfect square, and y squared is a perfect square because they're both even numbers. All right, so we're going to do our 2 parentheses. Square root of 9 is 3. Square root of x squared is x. Square root of 64 is 8. And square root of y squared is y. All right, and again, here we're going to put plus here and a minus here. And we're done. We're going to do number 9. I wasn't going to do it originally, but since we might as well, we're going to just finish it out. Now, if you look at 50 and 32, they're not perfect squares. Now, a squared is, and the minus sign looks like the rest of the problems we've been doing. However, this is where we need to pull out the greatest common factor. That's why we said always check for a GCF or greatest common factor. All right, so the biggest number that I can divide into 50 and 32 is 2, okay? So we're going to put a 2 here, and we're going to wind up with 50 divided by 2 is 25. And negative 32 divided by 2 is negative 16. All right. So now, isn't 25 a perfect square? Yes. Isn't 16 a perfect square? Yes. So now we're just going to come over here, do our double parentheses. The square root of 25 is 5, so put a 5 here. Square root of x squared is x. Square root of 16 is 4, so I'm going to put a 4 here and a 4 here. And this time, let's switch it up. We're going to put a minus sign here and a plus sign here. And now we've successfully factored using difference of squares. All right? Well, I left you a Google form for you to complete. Please complete it. Try your best on it. It is for a grade. Like I said, try your best on it. And when we come back together, I did give you the correct answers. And if you have any problems, when we come back together, I'll review those problems. Well, thank you, and I'll talk to you in the next one. Bye.